as I said, we are going to be covering chapters 4 and 6, and I did not create a detailed PowerPoint here, but here is a simple PowerPoint which just has 2 pages just telling you what are the topics that will be covered. Chapter 4 bridges the gap between statistics and data mining, so you can consider this to be a Statistics 101 course. The chapter starts by essentially defining the null hypothesis. Okay, what exactly is a null hypothesis, and so on and so forth. This is stuff that you already know from your previous course or from your background. Okay, so it isn't something that is new or anything like that. In fact, none of the topics in this chapter should be new to you. Okay, but if it is, well, you can always read the book because it does offer you an introduction to these topics. Then it talks about the probability values. Okay, the null hypothesis can be quantified, and the p-value is the probability of observing a difference as large as something that you observe. Okay, and then assigning some confidence level. Well, there is the 95% confidence level that this null hypothesis is valid or true or invalid, and so on and so forth. Okay, then the chapter moves on to looking at various ways of looking at data and measuring data. So it talks about histograms, it talks about time series, and then it talks about something very important, and that's why I put it in uppercase, z-values, because what this is standardization of values. So you will be using z-values quite a bit. This is when, for instance, you're comparing apples with oranges. Well, obviously they belong to 2 different units, and therefore how do you actually measure this? Okay, and in some cases you'll find that the x-axis units are fairly easy to handle, may go from 0 to 10. The y-axis may go from 0 to 1 million, and so on. So for this, it is useful to kind of create this or compute the z-values by looking at the average, and then how many standard deviations separate a particular value from the given average. Okay, so that's basically what a z-value is all about. Then the chapter moves into a discussion of normal distribution, and it talks about the variance that is associated with that and the standard deviation, which is all, essentially part of normal distribution discussion. It talks about the standard error of proportion. Okay, and it also starts discussing about how to discuss multiple, do multiple comparisons. Okay, what exactly is meant by multiple comparisons? Well, in the past, you basically just looked at well, X versus Y, or what's the difference between 2 presidential candidates. But what if there are more groups? Okay, that's multiple comparisons. So one way to kind of look at this is by looking at Bonferroni's correction. Another way is by chi-square test, and then finally the chapter ends by discussing some common problem areas that you may encounter. Okay, so for instance, you may encounter problems such as measurement errors, okay, time dependencies, the fact that you're dealing with a lot of data, and some data may be censored, some data may be truncated, and so on and so forth. So that's basically chapter 4, and then we move on to chapter 6. We don't have chapter 5. So then in chapter 6, again, this is how to kind of connect data mining with statistical techniques. So it starts by first looking at similarity models, the rationale being the more something looks like what you're looking for, the higher its score. Okay, so for instance, if you're going to market something, a particular product, you're already marketing it very successfully in the state of New York, then you want to market it to Vermont. Well, you start looking at the counties in Vermont that is very similar to the counties in New York where you've been able to successfully sell your product. Okay, so that is your basis of similarity modeling. Okay, and then you kind of create a table and then look up tables. Okay, you create a table and you say, well, if there is this property and that property, then this is the rate of success. Okay, and then you find another town, a totally new town in your sample, and then put it into a cell. Okay, align it with a particular cell, and then say, well, this is where the X property is, this is where the Y property is, and therefore this is where it will fit in, and then by virtue of fitting in here, it is either similar to my town or not. Okay, so you look at those sorts of things, and then of course this is good for comparisons between two variables. Then you go on to the naive Bayesian model. You look at best fit analysis, okay, the best fit lines, and linear regression, multiple regression, and logistic regression, because linear regression and multiple regression essentially deal with X versus Y and so on. But what if your question actually is, you know, is it true or false, and so on? Okay, how do you do those kinds of you know, comparisons and analysis? That's where you get into logistical regression. And then you also look into things like fixed effects and hierarchical effects, and all of those things. So essentially it is a lot of statistics, and therefore it is fairly basic in the sense that you already know about this. If you don't, you can kind of read this. Both chapters 4 and 6 are fairly easy and fairly descriptive, so I hope that you will not have any problem in looking at these topics. Okay, so that's basically what I have for you as a synopsis.